Hello everyone, welcome to another video on rank of a matrix. How can you find the rank? So in the previous video we have seen how we can find rank for a 2 by 2 matrix, but in this video we will see how we can find a rank for a 3 by 3 matrix using echelon form. So first, what we have to check whether this is in echelon form or not. No, it is not in echelon form. Next is that we have to find which is the pivot element 2. So let's make it 1 first. How can we make this 1? This can be made 1 by dividing by 2. So let's do R1 means the row 1. We are dividing row 1 by 2. So if we divide 2 by 2, it will be 1. 4 by 2 is 2. 2 by 2 is 1. And we keep the remaining elements as same. So what row operation did we perform here? We performed dividing the first row by 2. Now, so this is A. Now, what we have to do? We have to make it in such a way so that these elements become 0. Means number of zeros should be more here, a bit less, one less here, and so on. So if you observe carefully, we see that if we subtract the first row, elements of the first row with the third row, 1 minus 1, it will become 0. 2 minus 2, it will become 0. 1 minus 1, it will become 0. So what we can do, one row operation we can perform is R3 minus R1. This we can do. And one more, for the second row, what we can do is that 1 minus 1, 3 minus 2, 2 minus 1. In that case, the first one will be 0. So that means R2 can also be made R2 minus R1. In this case, 1 minus 1 will be 0, the third row. 2 minus 2 is 0. 1 minus 1 is 0. 1 minus 1, 0. 3 minus 2 is 1. 2 minus 1 is 1. And rest 1, 2, 1. Is it in echelon form now? Yes, because the leading zeros are increasing as we move from top to bottom of the matrix. So here we have 1 leading zero, here we have 3 leading zero. Now how many non-zero rows are there? It is in echelon form. How many non-zero rows are there? There are 2 non-zero rows. Therefore, rank is equal to 2. So I hope it is clear. So what we are doing, we are using some row operations and finally converting it into echelon form and finding the rank. Let's look into another example of finding rank. So it is also a 3 by 3 matrix. And what steps can we apply? I am showing each and every step. So the first thing is that we have to check whether the given matrix is in echelon form or not. No, it is not in echelon form. So we can move to the next step to make the pivot element 1. It is already 1, so we need not do any operation to make it 1. It is already 1. Now our next target is to make, already there is a leading 0. So we have to make these 2 zeros, or 1 0 and rest another. So what you can do to make this 0, the operation that you can perform is R3, because we have to perform the operation on R3. So R3 equal to R3 minus 2 of R1, because if we multiply this by 2, then 2 minus 2 it will become 0. So we can put 0 here. So 2 means R3 minus 2 into R1. That is 2 into R1. That means 2 minus 2 is 0. 3, R3 is 3, minus 2 to the 4, that means it is minus 1, 4 minus 4 is this R3, 4 minus 2 of 6, so sorry, 2 of 3, that is 6, 4 minus 6 is minus 2, so that is in R3. So we are doing the operation on R3 only, so rest will be same, so 0, 1, 4 and 1, 2, 3. What about the next step? Is it in echelon form? No. Why no? Because this is having 1 0, this is also having 1 0. The number of leading zeros should increase as we go from top to bottom. So you must be very careful. So here it is same. So it is also having 1 leading zero, it is also having 1 leading zero. So it is not in echelon form. So you have to convert it into echelon form. So how can we make this 0 now? So if you observe carefully, if we add these two rows, 0 plus 0 will become 0, minus 1 plus 1 will become 0, and minus 2, rest will be same. So 0, 1, 4 and 1, 2, 3. So that means what operation are we performing here? R3 plus R2. So we are adding these two rows because it is minus, it is plus. So if we add it up, we will get 0. So now here we have 1 leading 0, here we have 2 leading zeros, and therefore it is in echelon form. So how many non-zero rows are there? So we have 3 non-zero rows. So therefore rank is equal to 3. So since we have 3 non-zero rows, therefore rank is equal to 3. So we have to be careful. This example, what this example shows is that although both of them are 0, I am repeating it once again, although both of them are 0, but it is not in echelon form. Then it will be in echelon form if the number of leading zeros increases as we go from top of the matrix to below. So that's all for this example. We will look into another example of 3, say 4 by 3 or 3 by 4 matrix after this. Okay. So let's look into another example of finding rank. All the previous examples that we have seen were 2 by 2 matrix or 3 by 3 matrix. So in this example, we will be looking into a matrix that is 3 by 4. It shows that it is echelon form is not only limited to square matrix, the matrix can be square or non-square matrix also. Means it is applicable on any type of matrices. So how can we do this? So first, what is the first criteria we have to check? Whether it is in echelon form or not. No. Next we have to see whether the pivot element is 1 or not. Yes, the pivot element is 1. So now we have to transform the other rows. So what is the what we need? We need leading zeros. So what can be done? How can we bring zeros here? So if we multiply this row by 3, then 3 minus 3 will become 0. Our main target is the first element first and then the others. So row 3 can be obtained by subtracting row 3 and 3 into row 1. 3 into row 1. We are multiplying the first row with 3 and then we are subtracting from this. So 3 1 are 3, 3 minus 3 is 0, 3 2 is 6, minus 6, 0, 3 1 is 3, 2 minus 3 is minus 1, 3 minus 3 is 0. So 0, 0, minus 1, 0. What can we do for this? Similarly, we need 0 here. So we can multiply it by 2 and then subtract it. Means R2 can also be done the same. R2 means this row minus 2 into R1, twice of R1. So 2 under 2, 2 minus 2 is 0. 4 minus twice of this. So 2 2s are 4, 4 minus 4 is 0. 1 minus 2 into 1 is 2, so it is minus 1. And 2 minus 2 of 1, 2 minus 2 of 1 is 0. And the first row will remain as same, 1 2 1 1. So is it in echelon form? No. Why no? Because although we have 2 leading zeros, but the leading zeros are same. Here also we have 2 leading zeros, here also we have 2 leading zeros. The number of leading zeros should increase as we move across the matrix from top to bottom. Now how can we make this 0? If we can make this 0, it will come in echelon form. So we will not change this one, but we will try to change this. So how we can do? So if we subtract row 3 by row 2, in that case this will become 0, because minus 1 minus minus 1, it will become 0. So the first row will be same. So second row, let it be same. We are not changing the second row. For the third row, what we can do is that for the third row, row 3 minus row 2. Row 3 minus row 2. So in that case, we will get 0, 0, 0 and 0. Now it is in echelon form. Can we convert it further? Can we make all these zeros? No, because if we perform any operation with this, these elements will change, will get changed. So this is the final echelon form. So how many non-zero rows are there? There are 2 non-zero rows. The last is a 0 row. So 2 non-zero rows are there. Therefore, rank is equal to 2. So since there are 2 non-zero rows, therefore the rank is 2. So this is the way of finding rank using echelon form.